So yes,
Right.
RB subcarriers.
Rakesh, okay, I'll call you back. Then, okay, let me start. Can anyone tell me, right, what is a RB size, then what is the RE, what is RB, what is RE, then what is the size of RB in terms of kilohertz? How many REs are there per one RB? Small quiz time. Hmm?
Like in 50 megahertz, 75 RBs.
Hmm.
Yeah, and
Hmm.
like in one RB, like 12 subcarriers.
Hmm. Okay, fine. Right. So we have seen that we have two types of symbol duration, right? Two types of symbol duration. Okay. One is normal CP and another one extended CP, right? We are calling in normal CP 7 OFDMS bulbs. Okay. Whereas in extended CP, OFDMA. Why we are calling here, right? And what exactly this cyclic prefix? What exactly this? What exactly the cyclic prefix? So, in generally, right, when let us take, I am talking about only one signal. Okay. So when, right, this is antenna, one signal is transmitted. Okay. So let us take maybe trees, maybe buildings, right? And also earth. Okay. It reaches like this. It reaches like this. Right. There will be a straight line. Okay. This, of course, there will be multiple paths. Okay. So this is a direct path. Right. So maybe this is, I can say, D1 distance T2. This may be D3 plus D4. So definitely, right, always remember only one thing will be only one pulse will be transmitted, or one symbol we use to say. This is a symbol, okay? Always only one symbol will be transmitted. This symbol, right, when it is radiated into the air, okay, it will right, disperse, okay, into the space. So let us take, this is the uh, symbol traveling directly, and this is another symbol traveling indirectly, ID1, indirectly one, this, right, another symbol, right, all three, right, this when signal is radiated into the space, it will disperse in the space. Okay. So this is, let us take ID. So definitely speed, right, depends, or you can say right? For example, if someone started from A to B, okay, place A to B. So he can go like this, or he can go some city, right? City A to city B, right? He can go like this, right? He can go like this, right? So definitely there will be uh, different paths from A to B, right? Definitely, if I say this is the direct path, right, he will reach little early compared to this because the distance is more here, right? So here also, right, I can say this symbol, right, reaches here. Let us take, this is time t, in duration time t. This symbol reached, right, as the distance is longer, delay will be there. Okay, so delay will be there like this. Okay, this reached at t1. Then another, this one, okay, like this traveled like this. Then because of the distance, it is reaching like this. You can see now, symbol I transmitted only one, but I received here is multiple copies of the same. Multiple copies of same symbol, which results in, right, which results in interference, right, which results in interference. Got my point? Which results in, means one symbol falls on another, one symbol falls on another, right? If I transmit another symbol also, right, this is, let us take symbol 1. Next I started transmitted symbol 2. Okay, now you can see another symbol travels and creates multiple symbols, right? So generally one symbol falls on another symbols and creates, right, some kind of interference here, these positions, right? Here it will be inter. This is time domain signal. If I convert this into frequency domain, right, so it will look like this. First symbol, next symbol, right, it will, means there will be a overlap between the symbols like this, like this. So here overlap means we call this as an interference. So interference, okay. So if I transmit some data, right, if I transmit data here, if I transmit data, this data will be lost. Okay, if I transmitted data around this, right, due to interference, data will be lost. Got my point? Data will be lost. So in generally, for in digital communication, if single single carrier, if single carrier is transmitted, all right, a signal or this interference can be, this interference can be removed with the help of equalization technique, right? There is a digital communication techniques, equalization techniques. All right, it can be little easy to remove this, but here why we are talking about, see, single, right, only I am talking about only one carrier which carrying the symbol created interference, but we are talking about hundreds of carriers. Got my point? Hundreds of subcarriers, right? In the last class, we have seen, right, for 20 megahertz, just 1200 carriers. Just imagine 1200 carriers carrying the 1200 separate symbols into the space and refracted and received at the receiver. Just imagine how much interference will be there. Got my point? We cannot, right? Just see signal false like this, false, so many symbols. So this will be extended, right? So if I take two scenarios, one is the rural scenario, right? Means like all this reflection, reflection, signal reflection, refraction depends on the terrain where we are, right? For example, rural area. Rural area, most of the times it is plain, right? So reflections will be less. But in urbans like Hyderabad, definitely all are building concrete buildings. Then there will be a huge reflections, refractions, which creates a complete interference where we cannot get the data. So why, how this CP is using, means how this CP is helping. So if I take this, this is my symbol, right? Right, just we have seen if this symbol is right. Okay. Okay. So now like this, like this. So many symbols, if it is falling, right, this portion will be extended. If I transmitted any data here, that will be lost. What am I doing? I am not going to transmit any data here. I am keeping it. I'm not, see, because of the signal nature, right? Data will be lost due to interference. Data loss due to interference. So what am I doing? I am not transmitting. This I am calling as a CP, cyclic prefix, right? Cyclic prefix, right? Mathematically, how cyclic prefix, right? For example, if there is a house, if there is a house, if this house is abandoned after 1 year, 2 year, 3 years, after 10 years, what will happen? Inside, right? Maybe plants, trees grow, right? Anything can happen in abandoned, right? Empty house. So here also, data will never transmitted empty. What they are doing, what they are doing, whatever the data which is transmitted, the front portion of here, front portion filling here. That's why prefixing, prefixing. This is prefix, cyclic, cyclically means from this here, right? Where here from next symbol, from next symbol, right? Next symbol will be look like this, right? The next symbol will be look like this. So here data will be transmitted, so transmitted here. So simply I can say this portion of data will be filled here. This portion of data will be filled here. This is a continuous cyclic process. Means no data is transmitting here, but the front portion, right? Already data is here, data there here. If I transmit, if I fill this data here, anyway this is going to last. I don't mind it. Data is there here, right? Just prefixing instead of transmitting empty symbol. This should not transmit empty, right? So that's why what am I doing? Prefixing this data. Anyway, data is there. Even if we lost here, I don't mind. Lost, don't, no problem. Got my point. So this is cyclic prefix. Okay. So right here, this symbol, right? This symbol is filled with it. Here, this. Got my point? Prefixing the data which is transmitting in symbol. Clear? Hello?
Yes.
So I am not transmitting any new data here, but taking some data, filling the empty space and transmit it. So this is called cyclic prefix. Yes, right? You can see one symbol, right? The front portion is taken and filled in the front portion to back portion. So that is what cyclic prefix. Okay. It's okay. Any question? You are late, na? Right. So here it is a small explanation. Right. When we transmit a symbol into the air, this symbol can reach from different paths. Not only these three, right? If building is there, it can come like this, right? If something is there, right? Even human body, right? Even a human body, right? If signal impinges on human body can also reflect the, right. So human body also. So means, right, every object in the space can reflect, means signal. Generally, object will consume some signal, some power, and reflect other power. So that's why if we are traveling away from the base station, right, when we travel away from the base station, right, we don't see signal. This is because, right, signal get dispersed in the space. Power of the signal will be dropped because of, like, right, it impinges on the earth, impinges on the walls of building, trees, humans, right? So that's why means everything consumes this signal. So that's why we don't get a proper signal, right? So when this symbol get dispersed in the space, it may, right, impinges on different objects and reflects, right? Simply I can say reflection, reflection, refraction, and diffraction, refraction, and diffraction. Okay, because of these effects, right? Because of these effects, right, one symbol falls on another symbol, one symbol falls on another symbol, which creates an interference here. Okay, which creates an interference here. If I plot, this is time domain signal, if I plot frequency domain, right, so this portion will be the interfere portion. Means due to interference, I cannot receive any data from this portion. Means if data is transmitted here in this place, that will get lost, or that will loss. Okay, clear? So that's why, right, I cannot transmit, right? If I talk only with one symbol, I am talking here, but I am going to transmit 1200 and symbols at a time, 1200 symbols at a time on 1200 subcarriers. Just imagine 1200 subcarriers are transmitted, 1200 symbols simultaneously transmitted into the air, which creates a lot of interference, right? There is no chance to reduce the interference. No chance. Definitely, there is no chance. I cannot filter the interference out from this much of signals. Only the thing is avoiding the interference. I cannot filter. I cannot remove this interference through any technique. Only the thing is avoidance. Got my point? Avoidance. So this CP is a technique, interference avoidance technique. Okay, right? So CP, cyclic prefix, is a interference avoidance technique. Right? Once this interference is introduced, I cannot remove. So that's why I am taking care of not to transmit, in this interference portion, right? Just right, if I write one symbol, okay, then another symbol, okay, another symbol, then another symbol, okay, another symbol like this. So what am I doing? I am not going to transmit this. It is expected. This portion is interference portion. It is expected. For example, if something is right, we are expecting a bad thing in our life. Definitely, we will try to accidental things I cannot do, but expected things I can avoid. So here, this is expected portion of interference. Okay. Of course, lot of mathematical are involved here. Okay. Expected portion of interference. Right. If anything I transmitted here, if I transmit here, I will lose that data. So that's why what I am doing, I am not transmitting. No data transmission. Okay. I am not going to transmit. But right, data will be transmitted here only. Data will be transmitted here. This portion. Okay. But I cannot send the empty. This is empty, right? Empty. Yeah, I cannot send this empty. Right, as I said, I cannot send empty. Empty houses becomes right filled. Maybe empty houses or abandoned houses, maybe filled with tea trees or something. Okay, illegal activities may also happen here, right? Similarly, I cannot send this empty. So what am I doing? I am taking some portion of data here, here, here. Already data is there, right? Some portion of data I am filling here. As I cannot send this empty. Clear? Yes, clear? So this data, this portion of data I am filling here, right? Right, means prefixing, right? Prefixing. So this is right prefix. Right, what I am doing? Prefixing, right, data cyclically, right? Cyclic. So this is called cyclic prefix. Means one symbol, means like front portion of the data will be filled in the CP portion like this. And so, got my point? Right? And no doubts, right? Now, what is normal CP and what is extended CP? Let's take what is normal CP and what is extended CP. What is normal CP? Right, in the last class we have seen in normal CP 7 symbols. Okay, 7 symbols per slot. In extended CP, 6 symbols per slot. Why? What is the slot duration? 0.5 milliseconds. Correct or not? 0.5 milliseconds. Got my point? So let us take the 7 symbols, 7 boxes like this. But generally, I can take wherever there is a less interference. 1, 2, 3, 4, 5, 6, and 7. Right, as we discussed, this portion will be right. This portion will be CP portion. Okay, not useful to transmit. Correct or not? So this is called TCP. Okay. Type cyclic T. This is right data portion. T symbol. This total symbol. If I say this from here to here, symbol T symbol. Okay. Right. Data portion will be right. Data portion will be, I can say, T symbol minus TC. Simple. Okay. So right here, 0.5 milliseconds divided by 7 OFDMA symbol, and you will get each T symbol duration. Okay. But so particular area, right? Let us take urban area. Urban area where reflections, refractions, refractions, then diffraction, a lot of uh, reflections are there. Let us take, right? Lot of, so a lot of reflections. All concrete structures or trees, right? You can say, all right, dense like this. So definitely I can say there will be a huge reflections like this, like this, like this, right? More dense, right? More reflections. Means here I can say I'm calling here less. Let us take a rural area. This you can consider rural area, right? Most of the times rural area is a plain, right? I can expect the portion means less number of refractions and reflections. So I am right expecting smaller portion of symbol is reserved for C. But due to here, due to more and more reflections, right? Definitely it is required. Definitely it is required. Right, more reflections means, right, this portion will be extended like this. Got my point? I hope you are able to follow me, right? More and more symbols, right? More and more reflections, more and more reflections. So this portion will be extended. Okay, this portion will be little extended. This portion will be extended. Right here also same 0.5 milliseconds, right? There is no change. There is no change of slot duration. My slot duration is same, correct or not? But this portion is, right? If I say this portion, I can say little extended, right? If I can say, if I take this TCP time, TCP, right? For example, this portion is TCP. This is extended portion. Extended portion. Yeah. Or else let me write different. I hope you are able to follow me, right? This is little extended. So this extended version in all symbols, right? Consuming one symbol. So that's why we are having only 6 here. 1, 2, 3, 4, 5, and 6. So definitely I can say this portion is little extended. Okay. Whereas this data portion is same here. Data portion is here and their data portion is same. Means I am extending this portion by consuming one symbol duration. Got my point? Clear? For this data, Means compared to this data duration and this data duration is same. So by keeping data duration constant, right, because it has to carry minimum data rate. Okay, so here one symbol consumed, so that's why we are calling it as extended cyclic prefix. Right here, definitely one symbol I am right, bandwidth is reducing, but the advantage is, right, avoiding interference. Okay, clear? Interference is very worst, right? Nothing, I cannot recover anything. Okay, so this is about the cyclic prefix. Right, I think many are absent today. Okay, right. So tomorrow we'll continue because others are not joined. I don't want to proceed further for now. Okay, we'll see tomorrow. Fine.
Yeah,
Any
okay.
doubts?
Okay, sir.
Right, right. Others has to join. So for now, I am closing class. We'll see tomorrow. Right.
Okay, sir.
Okay.